I should not have raged so hard at Toads last night. There's no way I'm making it to class today. It's truly mind-blowing how something as simple as sending an email involves so many technological functions, or protocols. The technical obstacles Roger's email must go through on the BobcatNet, in order for his professor to receive it, can best be explained through the OSI 7-layer network model. The OSI model provides a common language to describe a network, or a way to communicate with each other about the functions of a network, in terms of layers. Each layer in the OSI model defines an important function in computer networking, and the protocols that operate at that layer offer solutions to those functions. The first layer is the physical layer, which defines the method of moving data between computers. The network needs a physical channel through which it can move bits of data between systems. Cabling and hubs define the physical layer of the network. Once Roger clicks the send button to send his email to his professor, this data is transmitted through an unshielded twisted pair cable running back to the BobcatNet hub. The data link layer defines the rules for accessing and using the physical layer. Keep in mind that computer data, in this case Roger's email, is binary, which means it is made up of streams of ones and zeros. The network interface card, or NIC, which serves as the interface between the PC and the network, on his system sends this email, or binary data, as pulses of electricity. All networks transmit data by breaking whatever is moving across the physical layer into discrete chunks called frames. The NIC creates and sends, as well as receives and reads, these frames. Inside every NIC is special firmware containing a unique identifier called the MAC address, or Media Access Control Address, so that data is delivered to the right system. The frame begins with the MAC address of the NIC to which the data is to be sent, so since the professor is the recipient of Roger's email, his system's MAC address would be the first chunk of data in the frame, followed by the physical address of the sending NIC, which is Roger's. The email, or data, is next, followed by a special bit of checking information called the frame check sequence, or FCS. FCS uses a type of binary math called cyclic redundancy check, or CRC, that the receiving NIC, in this case the professor's NIC, uses to verify that the data, or email arrived intact. The NIC isn't concerned about the content of the data in the frame, it just simply takes whatever data is passed to it via its device driver and addresses it for the correct system. To summarize what's happening, Roger's networking operating system, or NOS, commanded its NIC to send and create a frame to transport his email to his professor's NIC. The logical link control, or LLC, is the aspect of the NIC that talks to the OS, places data coming from the software into frames, and creates the CRC on each frame. The frame is transmitted down the cable into the hub. The hub, in turn, made an exact copy of that frame, sending a copy of the original frame to every other system on the BobcatNet. Only Roger's professor's NIC, the NIC with the matching MAC address, will process that frame, while the other NICs simply erase it when they see that it's not addressed to their MAC address. Roger's NIC knew the MAC address of his professor's NIC because their NICs have communicated before, and each system stores that data. The professor's NIC uses FCS to verify that the email is valid. The professor's NIC then strips off all the framing information and sends the data to the NOS for processing. At the network layer, packets get created and addressed so they can go from one network to another. I'll get to what a packet is in a bit, but it's important to understand what Internet Protocol, or IP, is first. IP makes sure that a piece of data gets to where it needs to go on the network by giving each device on the network a unique identifier called the IP address, or logical address. It eliminates the concern about the type of hardware used for transmission. So, as you already know, the frame enables Roger's email to move from one device to another. Inside the frame is both an IP-specific container that enables routers to determine where to send data and the data itself, and an inner container called a packet. The IP packet contains the destination IP address, which is the professor's, the source IP address, which is Roger's, and the data that is the email. Each IP packet is handed to the NIC, which then encloses the IP packet in a regular frame, creating, in essence, a packet within a frame. When data, such as Roger's email, is sent from one device to another over the internet, that data can go through many routers before it reaches its destination. Routers use the logical address, not the physical address, to forward data. Once the packet containing Roger's email reaches the destination subnet's router, that router will strip off the incoming frame, check the destination IP address, and then add a frame with the appropriate destination MAC address that matches the destination IP address. The professor's NIC then does its job of stripping away the Ethernet frame, as stated earlier. The NIC driver knows how to communicate with the NIC to send and receive frames, but it can't do anything with the packet. The NIC driver hands the packet off to other programs, or software, that know how to deal with all the separate packets and turn them into, in this case, an email message. After Roger's email processes through the network layer, and the data is converted into packets, it then comes to the transport layer. This layer is basically responsible for assembling and disassembling software. The packets must be organized so that the professor's receiving system is able to properly process the data. The transport protocol breaks up the packets and gives each packet some type of sequence number. Roger's system embeds a sequence number into the data of the packet, which contains the email. By reading the sequencing numbers, the professor's system knows both the total number of packets and how to reassemble the data in the correct fashion. After the data has been embedded with a sequence number, and the packets are properly formatted for sending the packet containing the email, it then continues on to the session layer. In this layer, the session software directs the email to the proper programs. It is responsible for initiating and accepting incoming sessions, and opens and closes existing ones. The session software also has the responsibility of contacting the professor's system to ensure that his device is ready to receive the email before it is sent on its way. The session software must essentially connect applications to applications. In addition, it must handle all naming conventions by simplifying the identity of a computer by giving them a name, rather than using an IP address or MAC address as an identifier. When Roger's email reaches the presentation layer, it is presented in a form that the applications on his professor's system can understand. Standardized formats, such as PDF, allows computers running on different platforms to share data across a network. The seventh, and final, layer is the application layer, which defines a set of tools programs can use to access the network. It doesn't refer to the applications themselves, but to the code built into all operating systems that enables network-aware applications. All operating systems have application programming interfaces, or API, that programmers can use to make their programs network-aware. This enables Roger's professor to actually access and view his email.